So today we're going to talk about the chain rule and the product rule. And we're going to start off with the chain rule. And chain rule is all about composition of functions, with functions being inside other functions. And so f of x is the inside function, and g of x is the outside function. So I want to state g and I want to state f. So if I consider this as h, if I think about the inside function, well, f of x is the inside function, and that's going to be x cubed minus 2x squared. That's the inside part. But what is this function inside? This is inside the function that is x squared, right? So I would take this and plug it in for the x squared. And so there's f and g. On here, this one's a little bit more challenging because we have to manipulate it first. And so if I consider this, I know that h of x, I could say is equal to 2, and then 2x minus x squared to the power of negative 1/2 using our exponents. Okay, and so when we're doing calculus, we always want to use exponents as opposed to square roots. And so I rewrite this, pulling the bottom part up to the numerator and changing the exponent. And so now my inside function, this here is my inside function here. And so my inside function f of x is equal to 2x minus x squared. And then my outside function g is going to be 2x to the minus 1/2, because this here will be my x value. That's all of x. Okay, and so this idea of an inside function, outside function is really important when we're doing the chain rule. So let's define the chain rule. So if f and g are differentiable functions and h is equal to g of f of x, then f prime of x is equal to g prime of f of x. So the derivative of the outside function multiplied by the derivative of the inside function. And that's how outside function derivative times the inside function derivative. So if we said y is equal to g of u and u is equal to f of x, well, dy dx, then another notation will be dy with respect to du times du, this is u, with respect to dx. And so this differential notation for derivatives is also quite handy as well. What you'll see in your formula booklet is this particular rule here. You'll see it written as such down here. Just the outside derivative times the inside derivative. So what does that actually look like in practice? Well, if I consider f of x here, I want to find f prime. Well, recognize that this is my inside and x to the power 5 is my outside. And so I like to think about it as this. So when I'm going to take the derivative, I'm going to start with the outside derivative. So the outside, the 5 comes down, like in the power rule. And I'm going to leave f of x as is. This is the inside, plus 2x squared plus 1. And then I subtract 1 from the exponent, which is chain rule, times, so that's this part here. Then I have to multiply it by the derivative of the inside. Well, here is the inside, or here is the inside. And so I do the derivative of the inside, it's going to be 3x squared plus 4x plus 0. So this here is the derivative. Let's try a couple more examples here. So if I look at this, in order to do this, I'm going to first rewrite f of x. I'm going to rewrite it as an exponent, so it's x squared plus 1 to the power of 1/2. And then, so I know that this is my inside. So my derivative is going to be the outside derivative, so the 1/2 comes down, times what's inside the function, subtract 1 from 1/2 is negative 1/2. And then I'm going to multiply it times the derivative of the inside. So the derivative of the inside is 2x plus 0. And this simplifies quite nicely. Those 2's go away, and I get x squared plus 1 to the negative 1/2. Okay? You should pause the video and try this one on your own first. So before I do the derivative, I'm going to rewrite it as x squared plus x plus 1 to the power, well, this is going to be 1/3 and comes to the top, it will be a negative 1/3. And so now if I'm going to do the derivative, again, here is my inside part. I'm going to leave that as is, and I'm going to do the outside part. So the negative 1/3 comes to the front. I keep the inside the same. And then I subtract 1 from the exponent, which is negative 4/3, times the derivative of the inside now is going to be 2x plus 1. And there's no more inside to go, and so I am finished there. So that is your introduction to the chain rule. We do derivative of the outside function times the derivative of the inside function.